When approaching this equation, I would first start by estimating. To do a computational estimation of this equation, I would use a rounding method. For example, you might first start by rounding both terms to the nearest hundred. In this example, we would round 567 up to 600 and 178 up to 200. In this case, the estimated sum is 800. Another way to do it would be by rounding to compatible numbers. So 567 could be rounded to 550 and 178 rounded to 175. In this case, the estimated sum would be 725. Finally, if we were required to be more accurate with the estimation, I might round each item to the nearest 10. That would mean adding 570 and 180. Then we would estimate the sum would be 750. To solve this equation concretely with the base 10 blocks, I would first start by sectioning off a row for each of the addends and the sum, as well as columns for each of the place values. I would then systematically count and trade the base 10 blocks to add the terms together concretely. In this case, I would count the units first, giving me 15 units total. Then I would trade 10 of these units for a rod and place that in the tens column. Next, I would count the tens and add them together. I can again take 10 of these rods, leaving 4 tens or 40 in the tens column. Finally, I'll have to take a flat for those 10 tens and add it to the hundreds. Then I can count my hundreds. In total, I have 7 flats or 7 hundreds, and counting these all together, I have 745. The symbolic representation of this concrete example is similar to a traditional algorithm. We would write the addends, and add the ones for a total of 15 ones. I would trade 10 of those ones for a 10 and continue on adding the tens. I have 14 tens or 140, so I would leave 40 of those tens down in the sum, and I would trade 10 of those tens for 100. Finally, I can add the hundreds. In this case, I have 7 hundreds, giving me a total sum of 745. My personal strategy for this equation would be to break down the addends to find more compatible numbers, similar to what was done in the estimation that used more manageable numbers. For example, for the first term, I would think of the term broken down to 550 plus 17. The next term, I would break down to 175 plus 3. I would then add the two 3-digit terms designated by the color purple to get a partial sum of 725. The next partial sum would come from the remaining terms of 17 plus 3, which equals 20. I would finally add these two partial sums to come to my final sum of 745.